All right. You should probably get your mic on. All right. Welcome to United Astronomy Clubs of New Jersey. Since we have a number of people coming down and you're going to find yourself some seats, if you have any chairs, I suggest bring them over or sit upon, since it looks like you're a troop of scouts. So while everyone here is finding some seats, I want to welcome you all who are joining us here at United Astronomy Clubs of New Jersey in Jenny Jump Park in Hope, New Jersey. And for those of you who are also joining us online, because that is right, we do live stream these to both YouTube and Twitch. So if you're ever looking for something and haven't quite got out here, you can always join us online as well. Do hit those like and follow buttons. Let us know we're doing a good job. So you can also check us out on our website, uacnj.org. It's where you're going to find a list of all our upcoming talks, as well as talks we've had in the past, and information on our member clubs, because we are actually a club made up of other clubs. I need to move this. And one of the best ways to actually get into astronomy is to join your local astronomy club, not just for ease of access, but because they're going to have tips and tricks and also events that are closer to you. Because what I might find useful out here in a state park is not as useful, perhaps, if you're trying to observe in New York City. But there are clubs out in New York City, so do check them out if you're ever out there. In addition, you can check us out on our social media pages, our Facebook, Instagram. We have a Discord server, all great places to ask questions. And we do keep these presentations saved on our YouTube. Also a great place, if you have any questions that you didn't get answered tonight, do feel free to comment those on the saved video, and I will get the answers to them as soon as I can. All right, so for the people here, before we get into the presentation, there's a bit of a safety briefing. If you need to use the bathroom, that is the porta potty in back. To my left, your right, it is illuminated by red for ease of finding in the dark. In addition, after the talk, I will be manning the little gift shop in the museum area. Do feel free to check out the museum area. We have a display of meteorites and other astronomy items. I don't know how the sky is going to look later tonight, just because we are under solid cloud cover. But chances are we will have telescopes available for you to at least look at if we don't open up the scopes, because we don't want to get the very expensive equipment wet and injure the equipment. Injure was not the correct word. Moving on. So when we go to leave here, if we are driving, we are using our headlights. We do not like getting run over, and I'm sure you also feel the same way. And any flashlights we might have, because this is a state park and it is cloudy, it does get quite dark. Do try and keep any flashlights or any light source pointed towards the ground because we don't want to accidentally blind people. With that, you're not here to listen to me ramble on for forever. You're here to actually learn about 3D printed astronomy with Mark Sproul. Mark Sproul has a Bachelor in Science degree in Computer Engineering from Rutgers School of Engineering and a Master's degree in Mechanical Engineering from Stevens Institute of Technology. He works on embedded computer systems, specializing in low-level image processing, and his interest in astronomy started in the early 1990s, writing software to read and display image data from NASA Voyager, Viking, and the Magellan space probes. He has built his own observatory. He's also given talks on how he built his own observatory and works on large observatories in many other places, which I'm sure he'll tell you about because I forget all of them. And with that, here's Mark.
Hello, there we go. All right. Good evening. My name is Mark Sproul. I've been in astronomy for a number of years, and I like to build things. This is the observatory I have at home that I built pretty much from scratch. Pretty large 16-inch telescope, same size as the telescope we have back over there. So that's what I do. So what happened was this spring we have a conference in New York. It's called NEAF Conference, and I got interviewed about this telescope, and I got a lot of response, and Kim asked me to do a talk on 3D printed astronomy because of how much response it got and how much interest it got.
Sorry, not sorry.
No, I like doing presentations. So we're going to talk first a bit about 3D printing and the history of 3D printing, and then we'll go into how it's used in astronomy. So stereolithography, SLA, was invented in 1984 by a gentleman. There was a lot of patents. Then this is where we're going to go through tonight of these different things that happened in 3D printing. The very first 3D printer machine was called this, an SLA-1. It cost $300,000. I worked at Rutgers from 2000 to 2012, and I had the opportunity to use one of these machines. They used an epoxy, a liquid epoxy, and a laser to solidify it. And the stuff that got made out of it, so it sat on a tray just beneath the surface of the liquid, and the laser would draw on it, then it would drop down and draw on it. So you had this bath of epoxy. And then when it was all done, it would lift up. You really can't see it, but this is the layer here of the epoxy, and that's below it that is making the parts. When it's all done, it lifts it up, it drains off, and you have parts like this, kind of crystalline in nature, very, very good detail, but not very strong for actually you doing something with other than models. In 1992, fused deposition modeling was patented. The patent process, as people know about, is a way to protect intellectual property, and that is what slowed down the process into affordable because these companies had these big patents and they made lots of money for commercial use of these big printers. But the original patent of FDM, and why that is important, is FDM, the fusion deposition modeling, is what we use today. What we think of 3D printers today are all FDM. There's many other types, but that's the type you would be using for most that you would have at home. In 2004, and this was going on when I was at Rutgers and some students were working on this, a machine came out called a RepRap, a rapid reproducible 3D printer. There was another version of it called Darwin because it could reproduce itself. All of the parts that you could not buy at the hardware store, nuts and bolts, etc., you could print and make it so it could make its own, it could make itself. Therefore, they called it Darwin, and it actually evolved. That then became MakerBot. MakerBot was a big open source company. They were cheap. You had to learn how to use. They were a little bit finicky, but they were the first printer that somebody could go out and buy as a kid and have it in your house to use. You had to learn a lot about how to use it, but there was the first one that was widely available. Then in 2012, Prusa came along in Czechoslovakia, making modifications, and Prusa, which I'll talk a bit more about in a little bit, is one of the better printer companies today for home use. Now, we print in plastic. There's a lot of examples I have up here. My telescope is all plastic. This is the segments of the telescope. But we can print on a lot of other things. For example, metal. We can 3D print metal. And I think you all should go run out and buy one. They're only $1 million and cost $1,000 an hour to run. Where I work, we have many of them, but they're very big, expensive machines. But it can be done. And in some cases, it is cost effective for machining, and there are cases where you can make things that you could not make otherwise, other than 3D printed. Now, most people have heard about 3D printing, and many of you might have heard that you could 3D print metal. What you probably have not heard about is 3D printed optics. Now, we are in astronomy. Astronomy is all about optics. We can actually 3D print optics today. However, it's currently limited to about 2 inches, 2 inches diameter. So we can't print a lens like this, but we can print a 2-inch lens, very lightweight, very cheap, for things like rifle scopes, binoculars. And that's where it's being used. But it is possible to be done. How it works is beyond the scope of tonight's talk, but is really pretty cool about gradients in the plastic, and is printed with an inkjet printer. Think of taking your inkjet printer and changing the ink to plastic and have it printed out. The company that makes it actually uses a high-end HP printer that they change the print heads to print out plastic instead of ink. This is the printer that I use mostly, a Prusa. If you're going to buy one, this is what I recommend. It's about $1,000. Yes, you can get 3D printers for as cheap as $200 or $300, but this one has the reliability and the customer support. A lot of the other companies, you buy it, you don't get any support, and they're not reliable. I highly recommend paying the $1,000 to get one of these. If you want to go high end, you get a Prusa XL. I have one of these as well. This one's $4,000. This one has 5 print heads, so you can print 5 different colors at the same time. Really pretty cool. But this is for bigger projects and when you get into it more. And then you can go the other direction, a Prusa Mini for less than $500. Again, very reliable, very good customer service. And there's probably 30, 40 different companies making and selling 3D printers today. And yeah, a lot of them have good advantages, but this is the one that I recommend. We talked a little bit about what we can print, plastic. The most common material is PLA. It's a type of excuse me. It's a type of plastic. Talking too much. It has a low melting point, very cheap, a little bit brittle, but the problem, if you leave it in your car on the dashboard in the middle of summertime, it will melt. I use PETG. PETG is the same stuff the soda bottle is made out of. This plastic right here, very durable, a little bit flexible, and that's what all this stuff here is made out of. ABS, polycarbonate, there's even titanium with this, the PETG infused with titanium for strength and infused with carbon fiber strands for strength. So there's all kinds of stuff. There's filament that has wood in it, that when you're done you can sand it like wood. There's all different kinds of filaments. So this is my telescope, and what this started out with is I got this lens in the front, and it's a commercial lens, and everything is built around that lens. I designed this diameter to fit that lens, And then I made 9 of these, and they're connected together. But in optics, we need rigidity. So these 2 square holes in the bottom, afterwards you're welcome to come up here and look at this. There are 2 aluminum tubes in here running the full length to give it its rigidity, and it's just aluminum square tubes from Home Depot. Each one of these pieces took 19 hours to print. The filament is about $20 a kilogram. There's only, I think we paid $17 for this particular. There's only 2 kilograms of filament in this whole telescope. So my entire material cost is about $40 for the entire telescope. When you come up later on, you look inside, it's baffled. Refractor telescopes, we like to put baffle in them to block straight light. Even that is, you can't see that from where you are, but you come up later and look inside, you can see the baffles. Actually got some pictures. So this is what the segment looks on the 3D printer. And you just print it. I just use a CAD program to print it. In the back, again, you can't see it any good, but there's a black piece of plastic here that adapts to the focuser. Just designed it and 3D printed it. And on the inside, the baffle I talked about for blocking the light. So overall, a couple hundred hours of printing in this, a lot of fun, and it's a very good telescope. It is great for looking at the moon, very rigid, a lot of fun, lightweight. Now, not everybody can, I'm a mechanical engineer, computer engineer, so designing this stuff to me is pretty easy, but not everybody can do that. There are several websites, Thingiverse and Printables are the 2 most common ones, that you can go online and download stuff that already has been designed. This is a very popular telescope. It's a Newtonian telescope, and you can print or buy the parts. The threaded rods you buy at Home Depot. Everything else you can print, and you can download it. The mirrors that you would need to buy to make this work on eBay, I looked it up the other day, $45. So if you have a 3D printer, spend $45 on some mirrors and print it, you got a telescope. For less than $100, you got a nice 4-inch diameter refractor telescope. This is some other pictures of it. It's quite interesting. It's quite complex. It's a very good telescope, and it's a really good telescope. This is some detail of it. The bottom cell is adjustable. In a good Newtonian telescope, you need to be able to adjust the mirror. All of that is built into the design. You download it for free. There's no charge to download the designs. It had its original focuser that it came with, but somebody else designed a better focuser. So there's all these different options. And I searched on printables. There were over 100 different variations. What am I doing wrong? Over 100 different variations of things that you can buy, that you can download to modify the telescope. So it can be a very customizable telescope. Another really good one, again, you just download it and print it yourself. This is for doing imaging. The first one was for visual. This one is for imaging. All the designs are there. You just download it and print it. You don't have to figure it out. Instructions. Another picture of it. Again, it's just download it, print it, and the standard size printer, most printers are 9-inch by 9-inch by 9-inch. Most of these things will print on that size of a telescope, on that size of a printer. There's also some very sophisticated things. This one takes a bigger printer to print. It is a complete tracking system for a DSLR camera. You just take your standard DSLR camera, print all this out. It's got some motors, and it will do complete tracking for you. So you can turn, for 3D print, a complete, really high-end photography system. This one is a really high-end. This is a harmonic drive. If you want to go out and buy a harmonic drive mount, it's several $1,000s. You can print this and build it. Now, it is quite complicated. You can see from this diagram that there's a lot to the parts, but these little parts, screws and gears you buy, but all these other parts are pieces you 3D print. And you've got a modern harmonic drive mount for a telescope. Also very simple. 6 inches, a very standard size mirror that you can buy off of eBay, and a complete cell for doing a Newtonian with adjustments. These things you just download them and print them. Focusers, a bunch of different focusers. On this one, this is a commercial focuser. I should have 3D printed the focuser as well, which I may go back and do someday. But there's some really good focusers that you just download the parts to. A filter wheel. If you're doing imaging, a lot of times we'll use a black and white camera and color filters to get better information and better pictures. A typical filter wheel is $300. You can download it and build your own right there. This is a drive, a parametric slew drive, again for driving a telescope. Quite complicated. But the point I'm trying to make is the variety of stuff from really simple to very complicated, just 3D printed. Some pretty sophisticated stuff you can make, or some pretty simple stuff. Now this is, again, where the 3D printing is not that complicated, but a pretty sophisticated system, a spectrograph. A spectrograph is something that allows us to take the starlight and spread it apart like a rainbow to analyze it for star composition. That's how we know how stars are what they're made of, by using a spectrograph. So on this, it connects to the telescope. The red thing is a camera. And this is how the light comes in. Light comes in the camera from the telescope into this is the view we're looking. Light comes in, hits a mirror, goes to here, goes to there, and this is the light path. So light comes into there, bounces to there, and then goes to the camera. To buy, you can buy one of these from a company in Europe. It's $4,000. You can buy the optics here in the United States from 4 Labs for $500 and build yourself a $4,000 spectrograph. And I'm currently in the process of making this one. I've got it printed out. I've got the parts, all the optics purchased, and I'm in the process of building it right now. And for those of you who don't know what spectroscopy is, we take a star, the top, we spread it into a rainbow, and that allows us to analyze the data and will give us strengths. And these peaks are different elements, hydrogen, oxygen. So that's how we know what the star is made of, by using spectroscopy. A similar device is called a spectroheliograph. This device is for specifically doing spectroscopy of the sun, very special purpose. Again, you download the parts. I think it's about, again, $300 or $400 worth of the lenses that have to go inside of it. But to buy one new is $5,000. And with that, you can get images like this of the sun, really, really high quality. I'll take questions at the end. High quality images of the sun. And these are images taken with that device. There's another branch of astronomy called radio astronomy, where we look at radio waves. And this is one that you can download. This one is large. This dish is about this big around, and it takes a big printer, but you can still print it on a big printer. It's got a lot of pieces, but the design is already done. There's also a lot of learning tools. This is a sphere which allows us to calculate the positions of the planets and the stars and the planets and the moon. Back before we had computers, they used to use mechanical devices like this so that somebody could have it sit on their desk so they'd know when the phase of the moon and such. Very popular in antiquity. This is another one like that. That's got the sun, the moon, so you can help you determine the phases of the moon, the seasons and such, all mechanically. Again, before we had computers and modern calendars, this type of stuff was done. Of course, we've got a lot of toys as well. A moon lamp. I'm in the process of printing these out. These take a little while to print out. The moon has got all the texture of it. You put a light bulb instead of it, you got a moon lamp. This is one I just found recently that I want to try to use. It's a mold for making a moon candle. Download it, print it out, and I can make all the moon candles you want. And a lot of models. Model of the Hubble spacecraft, a model of the Saturn V rocket, which I just printed this today. Print it out, and you can now put it together, and you've got a model of the Saturn V rocket. Kim mentioned that I started off working with images from Voyager. I found a model of the Voyager spacecraft. And these are some links to the stuff I've used. And now I'll take questions. You had a question?
All right, so hold on. Who had the question? Because I'll give you the mic. So other people can also hear the question.
What is it? What am I supposed to say?
You were asking
You had a question.
Oh, yeah. My question was, I was just going to tell him that the thing
It's all
fell.
right. It's okay.
And
These are models that I've made. This one.
All right, so since it looks like we're going into question and answer session, and that was kind of abrupt, how question and answer is going to work is you're going to raise your hand. I'm going to bring you the mic. You're going to say the question into the mic and then hand it back, and he'll answer to the best of his ability. Or if it's something more general, I may also answer if I happen to have the answer and he doesn't. Okay? Online people, if you also have questions, because I know there's a couple online people, you have the easy thing and just type it in chat. I do have my portable handheld internet. All right, so your question.
what do all of those thingies do?
Okay. This you're talking about?
And you might want to bring that back onto camera.
This is for my dome. This is an encoder, so this rides the wheel, the drive wheel, and this is an optical encoder for my dome that I have at home. If we go back. Yeah, the very first slide.
You might also want to mention what the encoder does.
All right, so if you see this white track here, you might be able to see there's holes in it. That is the track that a motor goes to drive the dome, spin the dome. This is something I'm currently working on that will ride in there. And this is an optical. This is for an optical encoder so that my computer can know where the dome is. So this is an encoder for where the dome goes. And it rides in that same track. These are bearings, and it will spin around as the dome spins so the computer can read where it goes. This is a model of a telescope I'm getting ready to build. This white part is the mirror. That mirror is 20 inches in diameter, and I'm making a scale model of it so I can figure out how it's all going to go together as I design it. So I do a lot of this where I print models out in small space to figure things out.
All right. I'm going to come back to you because there's other people who also have questions, and we want to give them a turn, okay?
Can I have the Saturn V rocket thing over there?
Yes, I was planning on giving it out to you, to somebody.
Yes.
I only brought one. He asked first, sorry.
Thank you.
All right, we had a question out here.
What inspired you to study astronomy and computer science?
2 different questions. Computers I got introduced to computer when I was in high school, and within 20 minutes, I loved it, and I was really good at it. I've been programming computers for 48 years, still love it, still do it, still very good at it, still make a very good living at it. Astronomy was kind of interesting. I was starting to write imaging software in the early 90s, and I stumbled across these CD-ROMs from NASA with images from Voyager. And I found it very interesting of these images, writing this image and processing software, dealing with these images, and it got me interested in astronomy. A friend of mine who was very into astronomy talked me into jumping in the deep end, and that's how I got into it. So I got into the astronomy through the computers. I got into computers. Now you have to understand something. When I started in computers, no one had a home computer. Home computers did not exist yet. You cannot think of a world without a computer at home. I started in computers in 1977, and there were no home computers at that time.
The computers were the size of the house.
So,
Right. To give online people a chance, this is going back to the beginning of your slideshow. Isn't the kind of 3D printing called resin printing when you were talking about the epoxy?
yes, that's what it's called today. It was originally called stereolithography. The proper term today is resin printing. They are the same thing.
Okay, and you had a question.
Is there actually a gift shop?
Yes, right in there.
Right, so we have one more out here.
Were you ever allowed to come? Were you ever in space?
No,
Okay.
no. Not very many people in space. You have to be an astronaut, work for NASA. I'm an engineer. I design the stuff.
About the closest most of us have come is having had to have Benadryl and then you're zonked out. Because you can't be allergic to something if you're unconscious, apparently. Right, so you already asked, were there any questions over here? Oh. Yeah. I just want to make sure that I'm not ignoring people behind me too.
Totally get that. All right, 2 questions. First question: do you have any more of those Saturn rockets?
No, they took like 3 hours to print. Honestly, I only found that design this morning, working on the presentation, and I tried to print out a second one, but it wasn't done in time. So I only found it. Honest to God, I only found it this morning, and I printed out what I could.
Okay, other question. My friend has a 3D printer. What was the most likely model that he could have?
Oh, that is. I have no idea. There's
There
so
are
many
so
different ones.
many
Like-
different ones.
Okay.
It's just my recommendation for reliability and customer support is Prusa,
Yeah.
but they're a little bit more pricey, $1,000. But you can buy one of the same size for $400. But the ones for $400, I recommend you don't take that apart till you get it home, so you don't lose anything. The companies, you're on your own. If it doesn't work, you got to figure out how to fix it yourself. Prusa has really good customer support.
All right.
Thank you.
Were there any more questions out here?
Kim?
Oh, there. All right.
I just want to ask how far you can see with the telescope that you made. You may have said it already.
This one, the only thing I've really done with it is the moon, because I don't have it on a tracking mount. The moon is fantastic on it. This is a 5-inch refractor. Put on the right mount, it could see very far. And that's a function of the lens that it is, which is a 5-inch. And 5-inch for a refractor is a good size telescope. And it's an f10, which is a higher power. So this would do very well. I've got, as I showed you in the first picture, my big telescope at home. So the only thing I use this for is bringing it out here for looking at the moon. But it would do a lot more than that.
All right. To give online another chance, would you ever consider 3D printing your telescope out of metal?
I can't afford it. The 3D print at my work, we have 3D printers that print titanium. The machine costs $1 million, and it costs $1,000 an hour to run. And no, I cannot get permission to do my home stuff at my work because it is so expensive. And doing a mirror cell or something out of we normally use aluminum, and then what we print is either steel or titanium. So yes, it would be worthwhile doing, but I cannot afford it.
Right. I know we had two over here.
Okay, I have two things to say. Okay, so first about my question. I forgot what I was gonna say, but the second thing was, can I go tomorrow to like see if I could get the thing you said has it 3D printed yet, so I could get it. So like once it's printed and I get here, can I just?
I live an hour and a half north of here.
No.
Does anybody have a telescope at home with a 2-inch eyepiece?
Wait, I actually had a telescope. It's my dad's, but I forgot what it looks like. But we still have it. I forgot what it looks like.
Carol, we have a question all the way in the Ken, we have a question all the way in the back.
Yep.
Okay.
Let me.
You have a question back there? Is it got a 2-inch
okay.
eyepiece on
Wait.
it?
The problem is without the hand, I'm kind of like, oh no. So, let me get to the person.
What this is a,
And show the people online kind of what it is.
this is the moon, and this is to go into your eyepiece connection. So these are 2-inch diameter. If you have a telescope with 2 inches, I printed a bunch of these out for anybody that's got a telescope with 2 inches.
Right. You had a question?
Do you have the instruction manual for this?
No, there is no. Go into printables.com and search for Saturn V rocket.
Okay.
But you should be able to figure it out. It's really easy.
Right. We're gonna do this question and then another online question.
That thing kind of looks like a rocket launcher a little bit.
Which one?
The
I
thing
think-
right there.
The telescope we
This is-
have on the dovetail mount.
It kind of looks like a rocket launcher.
This is another telescope that the lens. Just a minute. The adapter to hold the lens and the adapter to hold the focuser are 3D printed. It's aluminum tube with a lens on the end. But this is just another example of something that I've made 3D printed to make a telescope.
Right. Online people do get your questions in. I do want to wrap up question and answers. He'll still be here to answer questions. It's just I don't want to make the presentation go on for forever, okay? So the next online question is, do your models exist on Thingiverse or other sites?
No, because it's so special purpose. This is only for a Jaeger's.
It's just the wire you need to be careful about moving.
This is for a Jaeger's 5-inch cell, and they haven't been in business for 20 years. And I happened to get this lens set, 1999, I think I got the lens set, and I got it used because somebody had died, and I got the lens set, and it sat around, so it's not even available anymore. If it was available, I would gladly make the stuff online available, but the chances of anybody ever being able to use it, if somebody did have that and sent me email, I would be glad to send it to them. But going to the effort of putting it online when nobody's ever going to download it, I just haven't done it.
Yeah, I didn't know whether, because it looks kind of modular, whether you could scale up to the correct.
Again, you have to
and
design
then-
you have to design it for that size cell. And even another 5-inch lens set, the cell size might be a 1/4 of an inch bigger or a 1/4 inch smaller. Just depending on it might be manufactured differently.
Right, I know there was one in back.
Yeah, hi. I don't know whether it's a right question, but I heard like there are going to be some solar flares coming in. Do you know anything about it, or?
I do, but I don't know the schedule. The sun has been kind of active. There was obviously last October we had big solar flares. There were a few weeks ago. I don't know the schedule of the next ones, and they typically don't know until about maybe a week in advance anyway.
And I heard like it's gonna be pretty drastic
That
than compared to the previous ones.
that I
Is-
had not heard.
Oh, okay.
Yeah, you could go on to websites like NASA will have sections for it, like space.com. Usually, a lot of the astronomy-based news sources will talk about the flares as they come or when they're kind of expecting it closer, if that helps at all. Because that is one thing where sometimes news covers faster than we remember things. Was there any questions out here? Because I know I keep like spinning around to try and make sure I'm. And someone out here had one more question. All right. I'm going to take one more question after this, and then we're going to end the stream, and
Okay.
then you can ask more questions.
Like, is there anything else we can get? Like, thank you, thank you, thank you.
You got one already.
Yeah, you. All right.
No, you don't get two.
That's no more. All right.
What that is an eyepiece holder for just to get the moon on it.
It's a cap cover to cover where you would put your eyepiece. All right. Was there a question out here that I saw? Okay. So I think that's it for questions.
No, you already have
Uh,
one.
Just a
You
reminder.
I gave him one already.
All right, just a reminder. If you need to use the restroom, that is the porta potty. It's big, it's blue. In the dark, it is illuminated by a red light for ease of finding it. Through this door, surrounded by the red rope light, is a little museum area and gift shop, which I will be manning after we end the stream. It still looks pretty clouded over, so we do not have any scopes that can look through clouds because visual astronomy cannot do that. But chances are there might be people. Okay, so we do have a couple observatories open where you can at least see the telescopes. When we are going to leave, adult type folks who drive, please use your headlights. We do not like getting run over, and I'm sure you appreciate that sentiment. Let's not add to the medical bills. You are welcome to come up and take a look. Touch, ask questions on the display table. Do be careful because there is a telescope there. And even though it's 3D printed and I'm sure he could print more parts, let's not make that work for him. In addition, any lights, as it does get dark, please keep those pointed towards the ground. Like I said, great places to get more information, uacnj.org. It's our website. You can go. I'll be in there in a second, okay? And then also our social media pages. And you can ask any questions that you may have forgotten or see our past broadcasts. With that, everyone have a great night, and we'll see you later.
Bye.